This is Math 270, section R.3, finding domain and range. Before we start finding domain and range, we need to know how to represent our answer, and we do that using either interval or set notation. But in this class, we're going to focus on the interval notation. We don't use set notation so much. So the big thing to remember with interval notation is if you're including a point, or if there's a less than or equal to or greater than or equal to sign, you use a bracket. Otherwise, you use a parenthesis, and there's one more rule: you always use parenthesis around infinity. So if you can remember those three things, then you'll be in pretty good shape for interval notation. The other thing that we want to note about interval notation is if we look at, say, this first one here, parentheses a comma to infinity. If we were to graph that, we would want to make sure that we have the a and the parentheses going the same direction as it is in the interval notation, going to the right, because this is saying that it's all numbers a or bigger. So then we draw an arrow going to the right. But if we instead looked at the other case, go down here, negative infinity to b, in this case the arrow is going to the left because now we're saying all numbers up to b, but not including b because b has parentheses around it, so we don't actually ever equal b, we just get really, really close to it. Okay, so for some examples, I have a graph here and I'm asking you to write what the interval notation would be. So for this one, we're going to use the same, it says it's parentheses on the graph, so we're going to use parentheses on our interval notation. Parentheses -6 to 4 parentheses. Put that one, and B, we need to write each one of those in interval notation. So we have A. Well, we want to make our parentheses the same way as the graph, and there's a capital P there, comma. We usually draw a second arrow indicating what direction, but since the parentheses are pointing to the right, then we know that we're also going to the right. And then we would need, oh yeah, I can't type the infinity symbol. Alright, so we'll just do it this way. A is going to be capital P, comma, infinity. And then example B is, now P, the bracket's pointed to the left this time, so we know that we're going as low as negative infinity because that's as low as you can go. Noting that I'm putting a parenthesis around that negative infinity because we don't include it. Then capital P and then bracket. Alright, C, we have a bracket. It's almost exactly like A, but instead of a parenthesis we have a bracket. Again, we always put parenthesis around infinity no matter what. And then the last one's like B, but with a parenthesis instead of a bracket. Okay, so let me know if you have any questions on those. If we want to write C, example C in interval notation, since they both have the less than or equal to sign, that means we're going to use brackets on both ends. -4 to 4 with brackets around it. Okay. Let me try to clear out what's on this page here. Okay, number 3, domain and range of a function. The domain of a function will be the set of all possible real numbers that x can be replaced by, and the range is a set of corresponding y values. So I've got a little picture trying to demonstrate visually what domain and range would be. So domain is the red checkered line. It's how far left to how far right our graph goes. And in this case, the domain is going to be -3 with a bracket because we're including -3. Now, if it had a open dot on the end there, that would mean that we're not actually including -3. And I know it's not exactly on -3 because I typed it in Word, and you can't always get Word to do exactly what you want. And then it goes to about 8. Again, it's not perfect, but it was supposed to be -3 to 8. That's what I meant to draw there. So our domain is -3 to 8 with brackets. We're including both those numbers because there's no open circle on the end there. And the range, that's how far up and down we're going. That would be from 0, again including the 0, to 6, including the 6. And another thing is the domain of all polynomial functions is all real numbers, which is -infinity to infinity, or this funny looking R is another way we write all real numbers. Okay, so find the domain and range of each function. Let's see. I'm going to try typing this and see if I have any success with that. For A, the domain of that one is going to be all real numbers, and so is the range because it's just a polynomial function. I couldn't type this funny looking R, so there it is. B is not a polynomial function. This is the absolute value function, and if you recall what the graph of absolute value looks like, it's generally the lowest point it goes is 0 because the absolute value of a number is always positive. So it never dips below the x-axis unless you subtract a number from it. Like, for example, if I put -5 on the end there, then things would change because then everything would be either -5 or higher. But since that's not there, well, I can draw you sketch you a little graph here. Or here we go. Is it going to write for me? Yeah, okay. This is approximately what it looks like. So the domain is going to be all real numbers. You can put anything into that function, but the range, that's going to be the 0, including 0 to infinity. Let me see if I can draw a better graph for you. That one was a little sloppy. All right. Here's my grid. So absolute value comes down to a point at 0, 0, and then goes back up again. And this one's absolute value 2x. That just means that it's going up a little faster, a little steeper than a regular absolute value. So C is another absolute value type function, and that one will have a domain, all real numbers again, -infinity to infinity, or just R. And the range, it's going as low as -2 and including -2, and then it has no cutoff as far as how high it's going because of the arrow on the end of each side there indicates that it's going on forever. Alright, D, domain and range for this one, since it's it's just a line, and lines are polynomial functions as well. So these will be all real numbers. And E, domain of that is simply just 5. Since that's the only number in its domain, we just write this one. There's no interval notation, or we don't use interval notation to indicate just a single number, so I just say the set of 5. And the range is all real numbers because there's no restrictions on how high or how low that one's going. And then finally the last one, F. This one has a domain. It looks like it's ending at -9. And it goes as far east or to the right as 4. And there's no bubbles on the end. The bubbles, by bubbles I mean something that like that. In range, it's going as low as -2 and as high as 3. So if that bubble really was there, then this bracket that I'm erasing now would change to a parenthesis. That's how it would differ, because parenthesis means that you don't actually touch that number. All right, domain of rational functions. All right, domain of rational functions. We need to set the, well, remember that when you have a rational expression, you can't have 0 in the denominator. So to find the domain of a rational function, we need to find out if there's anything that when you put it in the function, it makes the denominator equal to 0. And there's a simple way to do that. You just take the denominator, set it equal to 0, and then solve. So in this case, when we put 6 in that function, we get a 0 in the denominator, and that means that 6 cannot be in the domain. So the domain for this function would be -infinity to 6, parenthesis, union 6 to infinity. Because remember, putting parenthesis around a number means that you're not including it. But we want to make sure we include all the other numbers, so that's how we do that with interval notation. The union in the middle just means and, so we want this set and this set. Okay? Well, actually mathematically it means or, but in terms of understanding the domain here, we want both sets as the domain. All right, part B, if I take x squared plus 4x plus 4, set it equal to 0. Well, this is a nice factorable one. It's just x plus 2 squared. And after you factor it, you can just take the inside the parenthesis part and set that equal to 0. And you see we get x equals -2. So I'm going to write it down here. The domain then would be -infinity to -2, union -2 to infinity. Alright, and the last one, again, set the denominator equal to 0 to see if anything will make it be 0. Sometimes there's nothing that does. Again, this is a nice factorable one. It's x plus 3 times x minus 3 equals 0. And that gives you two solutions, -3 and +3. So this time our domain is going to be quite long, -infinity to -3, union, -3 to 3, union, 3 to infinity. Okay? Let's see, I'm going to erase this now so I have room to do the last example. Suppose that $4,400 is invested at 8% interest compounded monthly for T years. So part A, the amount A in the account is a function of time. Find the equation for this function. Okay. Well, it's compounded interest function, so it's going to be A equals 4,400 parentheses 1 plus the interest rate over the number of times per year. So in this case, if it's monthly, that'll be 12 times a year, raised to the number of times per year times the number of years. So since we don't know how many years, we're just going to put a t in there to represent that amount. And then part B, we want to determine the domain of this function. Well, this really makes you think of domain in a different way. So this is not a polynomial function, so it's not going to be all real numbers. T is the only thing that's varying here, the number which represents the number of years. So think about what would make sense as far as number of years goes. We could put 0 in, it could be after no years. We could put 1 in, 2 in, we could put even 1.5 in. Really, we can put any positive number or 0 in, and we wouldn't have any problems computing the answer. Now, putting like 1,000,000 in wouldn't make sense since, we don't have accounts for that long, but it's still not going to give us an error. So our domain then is 0 to infinity, including the 0. Part B, the following graph approximates the number n in millions of hearing impaired people as a function of age x. The equation of this graph is the function given by the following equation. Answer parts A through C. What is the domain of n? Use the graph. Well, that's how far left and right it's going. So it looks like it starts at 0, including 0, and it ends at 90.4. And there's no open dot or anything there, so we're going to include that 90.4 too. The range, it goes as low as 0 and as high as 7. If you were marketing a new type of hearing aid, which age group expressed in a 10-year interval would you target? So we want where it's the highest. So that peak is right up here. Oops. Well, I can't get my arrow to move now. Let's see. There we go. There's a new arrow. We have a peak right there, and that looks like we want a 10-year interval. So I think 50 to 60 looks like the best place to put that. So write that, 50 to 60 is where that spike is. That is